Okay, let's look at this thing we can use called the vertical line test. This is a way to tell if a particular graph is actually a graph of a function or not. So let's remember some stuff from 5.1. What is a function and what is not a function? There must be only one value of f of x for any particular value of x that you plug in. So, for example, if you have something like f of 3 equals 7 and f of 3 also equals -7, that means this notation doesn't really make sense. This is not a function because you're getting two different outputs for the same input. So also, but if you had it the other way around, like if you had something like f of 3 equals 7, let's say, and f of, I don't know, 5 also equals 7, that's okay. You're getting two different inputs give you the same output, that's okay. But for any particular x that you plug in, you need to only get one output. Now, let's talk about what that means in terms of graphs now. So, if you have a graph of y equals f of x, that means you're only allowed to get one y for each x. You can't have two different values of y that come from the same x. You might have two different x's that give you the same y, but that's okay. So here's a picture of a couple graphs that describe some relationship between x and y. This first one, if you take any particular value of x here, whatever number on the x-axis you pick, you can see that each one is going to correspond with only one value of y. So, and you can see it if you draw these vertical lines, because if you pick a particular value of x, you're just going to get one f of x result that goes with that point. And that's true at all of these particular values of x. In other words, every vertical line goes through exactly one point. So this could be a function. Maybe I shouldn't say could be. It really is a graph of a function. You can say that. Then let's look at this other one here. If you take some values of x, like maybe this value of x right here, you can see that there's going to be two different values of y that go with that. So is this f of x, or is this other thing over here f of x? So this vertical line, again, represents a value of x that you're plugging in, and you get two different outputs, two different things that you're saying is f of x. So that means this is not the graph of a function. And basically what I'm doing is drawing vertical lines here. These dotted lines are vertical lines, and a graph represents a function if and only if every vertical line you can draw intersects the graph in at most one point. And we have that here, so that means this graph does represent a function. And with the second one here, that is not true. There are some vertical lines that correspond with some values of x that intersect the graph at more than one point. So it's not a function. Here's one for you to do. It was an example in the book, but I'm making it an exercise for you. Use the vertical line test to decide which of these graphs represent functions. Let's pause it here because I'll show you the answers in a minute, but you've got to try it yourself first. Here's the answers. This first one is definitely a function. Every vertical line you can draw, you can see intersects it only at one point. With this one, if there is just one value of x, such as x equals 1, and you get two different values of y with that vertical line, that means it's not a function. With this one, It's a little confusing because of this 2 here. What if you draw the vertical line that goes through 2? Well, it turns out that that line only intersects it at this one point here, because the empty circle means that the point 2, 3 is not on the graph. But the solid dot here at the point 2, 1 is on the graph. So that means f of 2 is 1, not 3. And that's the answer to that. There's one more section to cover in here about graphical solutions of equations and inequalities. I think we should cover it in class because it's a tricky concept and I want to be able to talk to you guys about it as we're doing it instead of just doing it in a video. So this is the last video for the section. See you in class.